Okay, so starting up the video, and a question's been asked about last week, the triangle one. And yeah, I'd be happy to look at your code, but before we do that, I'm going to go, where was that? File, new file, file save as. Where have I been saving these? ctemp SPA. Save as ctemp SPA, and then this was 2, and I'll call this 2/1/2018. All right, so I asked you to create a triangle, a function called isTriangle, and you had to take 3 arguments, A, B, and C, and then this is just one. So I'm saying if A plus B is greater than C, that should be true. So that's okay. I'm calling that test 1. So if A plus B is greater than C, it can be a triangle. But I have to test 3 different tests. If B plus C is greater than A, then test 2 is equal to true. If C plus A is greater than B, T3 is equal to true. I could go like this. T1, T2, T3 is equal to false, false. This is like stuff you're going to learn today. So you can do this. It's called. I'm pretty sure this will work. Okay, and then return T1 and T2 and T3. So this is just one way you could write that function. This is the function that determines if it's a triangle. So now we're going to test that function. Print is triangle ABC.
So you hit that print is triangle. Is that how you call the function? You have to put print in front of it?
No, I just want to see the result.
When I'm calling the function to execute, how do I just type? So I have the definition is triangle. If I just want to call that function in the program, how do I call it?
Like this.
Just that?
Yeah. And then if I want to assign the output something, I just say.
Oh, I don't have my parameters. That's why.
Oh, I need to feed it real numbers. And then I could say, output equals, and then I still have to write print output. So what this did is it first set T1, T2, and T3 equal to false. Now, we didn't cover that last week. That's something we're going to cover this week. So you probably said T1 equals false, T2, if you even did it this way. You could have done else statements. You could have said, if A plus B is greater than C equals true, else it's false. So there's more than one way to build the logic. But overall, the logic is all three of these statements have to be true. But there's different ways to build that logic. And so why did I use an and statement here instead of an or statement? Yeah, they both are, and there's actually three, so they all have to be true. So you're right. So if they're all true, then return. You're just going to return whether if they're all true. That's the only way that it's going to return true. If they're all false, then you're going to return. So now, if any of them are false, it's going to return false. So now when I run this, it's going to say false.
Why are you having to put those numbers in when you're calling that function 2, 2, and 5? Isn't that what when the user does their input?
Yeah. I'm just writing. So far, I just wrote the function, and I'm testing the function. But I haven't written that part. So your next task. So this was. If I go back to the assignment. That's right. Whoa, gotta go around again. So I've done this part right here. So it doesn't print yes or no. So I should actually say, if I'm looking at the assignment here, print. No. So right here I'm saying, if it's a triangle, print yes. If not, print no. But I'm also returning it so that it can be used as a function. All right. Now this says write a function. I did just mention that I meant a program in that case. That prompts the user to input 3 stick lengths, convert them to integers, and uses a triangle to check whether sticks with the given lengths can form a triangle. So all you'd have to do there is first collect those 3 numbers using raw input. So you just collect, stick 1, stick 2, stick 3, and then feed them into is triangle, and then you continue on. Does that make more sense? So this will be saved next time I post to GitHub. This will be saved, and then I'll just write right here, add code to get 3 stick lengths from user, and then add them, and then call is triangle with those values. And then finally report to the user if it can be a triangle in a complete sentence. And then you'd be done. All right, so you call this, and right now it's going to give you a true if it is a triangle and a false if it's not. So you could just write an if statement. If it's true, print yes, it's a triangle. If it's false, print no, it's not a triangle. Something like that. So yeah, that'll be up there. All right. Close that up. right, so today we're going to look at week 3, or M3 as it's called. One thing that I forgot to test is, just give me a second here, you don't have to do this. I'm just going to make sure this works. Because it worked the last time, but I think it's been over a year since I called this. Let's see, temp. Actually, I'm just going to put it right here, because I'm just going to close this. Okay, great. All right, we'll get back to that later. But you can tell that this is a function that just takes a text string and gets the latitude and the longitude. It did fail one year. I was using an ArcGIS routine, and they made it so that it costs money. But I know I switched over to Google at one point. Still looks like it works. Okay. Let's start off today.
Dr. Raver,
Yeah.
can I ask a couple general questions?
Sure.
Is it okay to use other programming interfaces like Visual Studio or Jupyter, or did ArcGIS include the IDLE just because that is fully integrated into Unity?
No. So IDLE is installs by default with Python on Windows. So
Right.
because ArcGIS installs Python, it installs IDLE, but you don't need to use IDLE to interface with ArcGIS. You could use a different Python interface if you wanted to. All the examples I'm going to use in class, though, I'm going to use IDLE, and later, when we get into ArcGIS, starting in a couple weeks from now, I will demonstrate that you can enter Python right in ArcGIS. All right. Any other general question that you have?
How would we get, you may know the answer to this, if we wanted Visual Studio on these computers in Jarkey Lab, what would we do with that?
The department does have a license to Visual Studio. Yeah. Yeah, I'd have to get somebody to install. Is Visual Studio on these machines? Yeah, it might be. Yeah, I could install it. Now, Visual Studio doesn't run Python, but
my version of Visual Studio runs Python, Dr. Raver. I've got Python Visual Studios as well.
Okay.
It's probably not compatible with ArcMap. I wouldn't risk it.
Yeah, I don't know for sure. Oh, I see that you sent me the email here.
I've got a whole languages that I can run on my version of this.
Okay. Well, yeah. I'll look into that. I'll look into getting Visual Studio installed on those machines and integration into Visual Studio.
Thanks, sir.
All right. Okay, so today, what we're going to talk about is actually there's two major topics. We're going to talk about a group of variables called sequences, or a group of data types called sequences, and we're going to discuss a new way to iterate. What does iteration mean again? We used the while loop as an example of iterating. So yeah, doing something over and over and over again. Okay? So the while loop just does something over and over and over again until something isn't true. But today, we're going to talk about doing something for every element in a sequence. Okay? But first we need to figure out what sequences are, because sequences was in that sentence about iterating and elements and all that. Okay, so a sequence is a data type that's made up of multiple elements. And I already let you know last week that a string is a sequence. I kind of talked about that before. So I can type in, my name is George. Oops, that looked really weird. George, right? And I'm making George a string and assigning it to the variable my name. How do we know that George is a string? Just by looking at that Python statement. Yeah, the quotation marks. Yeah. All right. C temp SPA. I just want to save this. Week 3, 2018. Example 1. All right, so that's not going to do anything so far. But we're going to go over a bunch of functions or a bunch of things that you can do with almost every sequence. One is that every sequence allows you to ask how long that sequence is. I got to print it in order for you to see it. So I can print how long this sequence is. So my name, George. I'm going to make these bigger again like I did before. What was that format? Options. Yep. Oh, that's the number of white spaces. Okay. 14. 16. That's not very much bigger. Let's just go all the way up to 20 here. You see that?
Yes, sir.
All right. I'll just make this full screen, and then when I run it, the other one will pop up, and we'll just switch back and forth. Okay. So a string is a sequence. So my name is George. I print the length of it. I could assign the length to a new variable, like name length equals, and it would store the length of my name in that variable. So now when I run it, I'll have the same effect. Are there 6 characters in my name? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yes. So that's the printing the length of a thing. Now, sequences, when we want to iterate or do something to every single sequence, every single item in a sequence, element. These are actually called elements. The things in a sequence are called elements. I can say for, and then I need to think of a variable name that I want to use. It might be good to use C. It stands for character. For C in my name, print C. Or I could do anything with C. Okay? Inside of a loop, this statement is going to run once for every element of the variable my name. And every time it runs through, C will be equal to the next element. So the first time through, C will be equal to what? Yeah, the first letter, which is G, and specifically a capital G, right? Second time through, it's going to equal E, then O, then R, then G, then E. Okay? So it's going to print out my name, like that. Still printed 6, but it also printed GEORGE, right? Just a little quirk of Python. If you put a comma there, it'll actually keep everything on the same line until it encounters a print statement without a comma, and then it'll keep going to the next line. Okay? So it just means for the next print statement, don't go to the next line. Anyway, it still has spaces though. All right, so that's printing each of the items. So this involves for and then the word in. For C in. So the general case is always for the name of the variable that you want to store the elements in the name of the sequence. The sequence is this value. All right. Now, your book also talks about the concept of an index. Now, if I, before the loop, set index equal to 0, and then inside the loop, I say index equals index plus 1, and then I also print the index, it's going to print separate there. It's going to print G and then the index. Now, there's really this here. Really, what if I put 50 right there? What would have happened? Well, I would have gone 50, 51, 52, 53, 54, 50. Okay. The index here is 0, and the reason that it's 0 is because I said it was 0, but that doesn't, well, okay. There is the concept of an index. There really is an index, and it really does start at 0 for all sequences. So this really is item 0, item 1, item 2, item 3, item 4, item 5. Okay? However, this was just a coincidence that they lined up because I started with 0. So one thing about sequences is that they have indexes, and the indexes start with 0. Okay? In fact, I can get any item out of a list. So now I'm gonna print a line like this. So we got a little space there. And then I'm going to print just my name, and I'm just going to ask for 1. So what character do you think is going to print when I do that? The E, exactly. The E will print. Why will the E print? Well, it's because the E is the item with the index 1. G actually has an index of 0. They're 0 based. So if I run this again, it's going to print, do this thing that, oops. Not that I was missing a comment, it was a quote. I missed a quote at the end of the statement. There we go. So see how it printed E right here? Printed E. That was the second item, but the index of that item was 1. Okay? All right.
You go back real quick to the code.
Yep. All right. Now, interestingly, I'm just going to do this in the Python shell here. Okay. Let's say I have a sequence, my name equals George. If I type in E in, oops, sorry, I need it in quotes. E in George, or sorry, my name. Like that. it'll say true. So this in operator does ask, you can use it to ask, is something in a sequence? And it'll return a true or a false. That'll definitely be useful in this course. So, you can get it to find the first instance of it. Yeah. Now you could write a function that would tell you that would return the index of all of them, which we can demonstrate. All right, so back on track here for a second. We can also do what we call slice sequences. Okay, when we slice something, like when I slice, like if I had a big piece of meat and I sliced it, I'm cutting a piece off, right? And you might say, well, let's just think of it like a bunch of brownies. Okay, I got a pan of brownies. I'm going to slice into the pan of brownies. You could say, I just want everything at the very beginning. I want all of the stuff that is on the edge of the pan because it's what I like. I don't know if you do. Or you like all the ooey gooey stuff in the middle, or you like just the stuff at the other end of the pan, which I guess will be the same as the beginning part of the pan. Right? You can do all that when you slice a string. You can ask just for the stuff at the beginning. You can ask for the stuff in the middle or the stuff in the end. Okay? Now, obviously, if I just want the one at the beginning, I just would say, my name and say 0. That's the one at the very beginning, right? I can write this is the one at the beginning. Okay. But how do I? What's that?
That square bracket you're using?
It is a square bracket, and that is required. Sorry, I should have declared that. It's a square bracket. So you index a sequence using square brackets always. All right. If you use regular parentheses, it thinks you're trying to call a function, and so it's looking for a function named my name. Okay, but if you use square brackets, it assumes that you are indexing an item in a sequence. All right. So that's how you get the item at the beginning of a sequence, right? So let's think, using the len statement, let's come up with a way that we could find out. Okay, first of all, if I wanted to get the last element in this list, what would I write? My name, bracket. What number would I put in there? 5, right? That would give me the last item. We already established that. Okay? That would give me the last item in the list. However, what if I didn't know how long my name was? Like, what if these were file names I was reading, and I wanted to find out the extension of the file name? So I wanted to get the last 3 characters, but let's just pretend it's just the last character for now. I want to get the last character. How do I get the last character if I have no idea how long it is? I could use len, right? Okay. Yeah. But what does len return? Right.
An integer.
It returns an integer, exactly. But what is the length return? It returns, in this case, 6, right? And we want 5. But is this number always going to be 1 greater than this number? Yeah. So the last item in the list is always going to be indexed as 1 minus the length. So we could, if we wanted to get just the last item, say something like the length of my name minus 1. So that's a little bit verbose, but that will work. So this right here will return a 6, minus 1 will return 5, and that'll give us the last one. This is the item, or the element at the end of the list. Okay? All right. Now, one more thing is when we actually go to slice, we can ask for a starting index and an ending index. So in other words, we can say, we want everything from element 1 to element 3, or element 1 to element 17, or element 2 to element 6, whatever we do. And so this is the way we can do that. We can say my name, and then we put the first element, and we include we include the one that we want. So the first one we want is 3, and then we hit a colon, and then we put the last one that we want, the last element that we want, which might be 4. Okay. Actually, no.
Those are the index numbers you're using there?
Yes, they are. I always forget this. Let me just run it. Let me print this. Actually, I should be printing all of these. I always forget whether, maybe I can just do it right here. I can test it right here. My name equals, print my name 3:4. So it just printed R. So it started at 3, 0, 1, 2, 3, and it ended at 4. So it wasn't quite what I said. So it's the number you want to start with, and then the slice ends just before the second number. So 3, 4 will only return one number. 3, 5 will return 2. So one way to think about it is the element numbers exist just before the numbers. That's the way the book describes it. So if you count from 0 to 4, you're going to get the first 3 items. The 0 item, the 1 item, the 2 item, and the 3 item. Oh, sorry, you get the first 4. Yeah, but you won't get the 4th item, the number 4 item. Just to experiment with it a bit. So if we change this to 5, then we're going to now get, we're not going to get the final element. See how we just got RG? Because it cuts it right before that one. So that's, I guess the one way to express that is, this is the 4th element to the, so it's going to be to the 5th element. I mean 4th element and the 5th element.
So Dr. Raber,
but not the 6th. Yeah.
If you use the 4 method, the 4C in my name, it starts from position 0. But when you use the my name brackets, it counts from 1. In plain English, if you will.
Okay, say that again. Sorry, I didn't understand.
Well, when you talk about 4C in my name, that line of code, it starts from position 0.
Right.
But then when we use the name of the variable my name and then we put something in brackets, it starts from counting from 1.
No, it starts counting from 0. See how my name 0 is 0, is the capital G.
Okay, but didn't it cut off the end when we did the link, the second to the last one where you said my name link my name minus 1?
That's the E here. That's the final E.
Okay.
Yeah.
I tried it, I got mine truncated, so I did 2 through 5 to the 3 through 5. And instead of doing, it started with 0, 1, 2, and then on 2 it did. And then it printed space number 2, then space number 3, and printed space number 4. But it did not print space number 5.
Yeah, so here, in a slice, the first number, it includes it, and the second one, it slices it just before it gets to that last one. So 3, this is the 4th element, so it's R, so that's 3. See, it includes 3, and then it goes all the way to 5 but doesn't include it. So it's just these two.
Right, so my point is that where you just highlighted the 3, if you highlight the 5, and you change that to the lem parentheses my name minus 1, you would never get the last character. You need to use lem.
Yes,
my name.
exactly. Yep.
Okay.
When you're doing a slice, the second number is the second number is a little bit different. Yeah, you need to go past it to get it. But the first number is the same. The first number is the same as this first number. See, if we started with 0, we are going to get, see, we're going to get starting with 0. Sit. Right, but 6 works too. I mean, you could put any number here. Yeah, with 6, you'll get the last one. Here, let me show one more time here. Now, the final thing I want to show is that there is a shortcut in Python. Say you want just the first 3 elements. You could say that I want, wait, just the first 3. No, that's, okay. Yeah, I guess you could do that. This will return, actually not the first 3, this will return the end. So this will go from 3 to the end. So that's actually what you would, like if you wanted to get the file extension, you could do something like that. So that's a shortcut. So from 3 to the end. So from the 4th element, which is referenced as 3, to the end. And then print my name. If you did the opposite, you're going to say, yeah. Actually, that wouldn't always be the file name. That's from the 4th element to the end. So if it had like 50 characters, you're still going to print 3rd to the end. Let's run this. So this prints the first 3 characters from 0 out to 3, which is the 4th element. So it gives you GEO. And all lists, all sequences, we're going to talk about lists in a second, you can do these for. Maybe that's an easier way to think about it right there. It goes from the start to the 4th element, but it's not inclusive of the 4th element. Okay, that second number is not inclusive. The first number is, the second number isn't. And you could even use negatives, if you want to get fancy. That'll be the same. That'll be -3. This will get us the last 3 elements. That's what I meant to do. Okay, RGE. So this would actually always give you the last 3 elements because it starts counting over from the left. So it goes 3 over and 2 to the end. So this is always the last 3 elements. That's the one that would be like the file name.
So you're saying if we throw a negative sign in there, it just will count from right to left at the end of whatever length the sequence is?
It'll count from right to left, just like you said. So you could go -3 to -2, which would give you just 1 element. You could actually mix them, like you can say -3 to 5, but you have to know how long it is. I mean, there'll never be any reason to do that. I don't think. Okay. All right, so that's string slicing. Now, some sequences are immutable and some aren't. So we'll talk about different sequences. Do you know what have you ever heard the word immutable? Like when somebody says, this something is immutable? What's that? Yeah, you can't change it. Exactly. You can't change it. It's not able to change. And so once you create a string, you can't actually change elements of that string. So you can't say my name 4 is now going to be equal to T. So I'm trying to change the 4th element to T. If I try to run this, I'm going to get an error. String objects does not support item assignment. So elements are not changeable. You can create a new string and put a whole new string in there. Like I could say my name is equal to GORTE. That's the equivalent. That's like what I was trying to do. I could do that. Oops. I meant to press enter. I could do that, but that's not changing the element in the sequence. That's creating a whole new sequence that has different values in it. Okay? So just be careful of that when you try to change items in a sequence. Not every sequence is immutable, but strings are. Okay? The one we talk about next, it won't be. It is mutable. You can change elements. All right, we talked about in already. Okay, I'm going to hold off. The book talks about. Yeah. Actually, this will be good practice. I'm going to stop this one. File save as, or file save, and then save this as. Or I'm going to write. This causes an error because strings are immutable. Okay, so save as. I'm going to call this example 2, and I'm going to delete everything except for my name. So we already established that you can iterate through a sequence, right? So there's a few skills that you could do. You could say something like, if C equals E, print found it. Okay. So what this does is when we run it, it's going to iterate through. Actually, I've made an error. Okay, what error did I make? It's going to iterate through and try to find all the e's, and if it finds an e, it's going to print found it. Okay, but what did I do wrong with this if statement in Python? Is that equal sign going to work? Is that going to return a true false?
You got to be double equal.
It's got to be double equals. So I'm going to get an error. Equal, not triple equals. All right.
Before you run that, Doctor, what exactly? So C, you're just using that's a variable you have to declare. What's that variable? Just a placeholder?
No. Okay.
For,
so
string?
when we write a for statement in Python, we say for, and then we come up with the name of a variable, and that variable can be anything we want it to be. It's a variable. We're declaring it right there.
Okay.
And it's each time through the loop, that variable is going to hold the next item in the sequence. So the first time through the loop, the C...
That's your storage variable, basically.
Yeah. The first time through the loop, C is going to be G, capital G. The second time through the loop, it's going to be lowercase e. The third time through the loop, it's going to be O, and so on.
Is there a reason why you use C?
I decided that C was short for character. I could use whatever I wanted to. I could call it, I could write out the word character. I don't think it's a reserved word. I could say letter. That might make more sense. So for letter in my name. But I came up with that. And in Python, you don't declare your variables. You just go ahead and use them. So we implicitly declared it there when we said for letter in my name. So now when I run this, it's just going to print found it twice because it found the capital G, the lowercase e twice. If I said G, it's going to only print it out once. And if I said, well, any other letter, I don't have any other repeat letters in my name. So it's always just going to say it once. Okay. So how come...
If you wanted to find the first E and stop, how could you do that? Did you just pass it after it found it?
Pass just does nothing. Like it doesn't exit a loop. It literally is just a placeholder. So if you wanted to exit the loop, you could. I think it's break.
Right. So that's how, if you only wanted to find the first of a type of something in a sequence, you break after.
Yeah, let's see. Let's see if that works with run.
Yeah.
Yep, that works. Just break. Break is the way to get out of a loop.
If you wanted it to print an integer that was the index space of where you found the E,
You're getting down into the questions I was going to ask y'all. So if I wanted to report the index, anybody have any ideas?
Yeah, we just did it.
Yeah, we did. Exactly. We did already do it. So we do something like, I'm just going to use I because I don't like typing it so long. I equals 0, and then each time through the loop, you need to say, let's get rid of this break statement. Each time through the loop, you need to increase I, and then just print I. So now, this is exactly like this is exactly like the loop we just wrote for the last one, except for we added this if statement in here. That's all we did, was add the if statement in. And so now it's only going to print the index when it finds it. So 1 and 5. So it printed 1 and 5 because it found an E at 1 and then again at 5. All right. How would I change this if I wanted to, let's just go ahead and copy and paste it down here. How would I change this if instead of reporting the indexes of the ones I found, if I wanted to just report the total number of that, the total number of occurrences of that letter? I could still use this, but let's change I to T for total. Okay? So I'm giving you a hint. So how would I make it so that T got bigger if it found an E, a lowercase e? How could I change this?
Plus equal?
Yeah. And where would I put it? That's the T equals T plus 1 or T plus equals 1. But where would I put that? Let's just get rid of all. We're trying to make T equal the number of times that I found an E.
Uh,
Instead of reporting or returning the positions, the amount of times.
Yeah, the amount of times I got to a T. So I want, the first time through the loop, T is going to, T is going to be 0 here, and it's going to find that it's a G. So do I want it to get any larger?
Yes.
I want to find the E, okay, but do I want T is going to be my variable that holds the total number of times I encountered an E. Okay, so let's go like this. Yeah, I mean, I think we're all in agreement that we're going to do something like this, T equals T plus 1 or T plus equals 1. Those are right, but where do I put those is what I'm trying to say. So the first time through the loop, a letter is going to equal what? T is going to equal what? Okay. The first time through the loop, letter is going to be G. We want it to be 0. Second time through the loop, letter is going to be E. So we want T to be 1 because it found 1. The third time through the loop, it's going to be O. We want it to be 1 still. R. 1. But T is the total number of times I've encountered an E. Yeah, because at the end I want to be able to report that you saw an E twice. G-E-O or G-E, 1. And then finally E, 2. So that's what, it's like a state diagram of what I want to have happen. G-E-O-R-G. Every time I get to an E, I want to increase T. But only if I get to an E. Right? That's what this does. Right here. This increases T by 1. So if I put this,
Does it not have to be indented? Oh, okay, there you go.
if I put this in here, when is T going to get incremented?
just when an E hits.
Just when the E hits, exactly. So now at the end, if I print T, and I run this,
You'll get 2.
I'll get 2, exactly. Yep.
I got 2, but I got a bunch of 1, 1, 1, 1.
You got a bunch of 1, 1, 1, 1?
I've got, yeah, mine's bring out 0, 1, 1, 1, 1, 2. I don't know what I did. P, I see. Indentation problem.
Yep. Okay, now why is this 5 printing right here?
Because your previous code.
Right. And the 1 is printing. So this is the index, that's an index, this is the number of times that we saw a T. So I could print for the user indexes of E, and then write number of times E appeared. All right. Now, it would be real useful if I turn these into functions where I could take E and say any letter, and perhaps even take my name and take any variable. So I'd have any string and be able to return the number of times a certain character appeared. Yeah.
So what we just went over, on the second part there, how does that different than the first part, first one?
Like this and this?
T? Yeah, just because you're using T, or?
Yeah. So you see how this I equals I plus 1 is not inside of the is not inside of, yeah. So because it's indented in here, it's only going to print those i's that meet this criteria. But still, the I is going to increment every single time through the loop. Here, the T is not going to increment every single time through the loop. It's only going to increment when it encounters an E.
Dr. Ray,
Yeah.
I hope I didn't interrupt that other student.
No, no problem.
Is there a way here to comment out multiple lines of code without putting the pound sign in front of each line? Like select, like that. I can't really find anything.
You still have to put a pound sign in between each one, but you don't have to do it manually. Did you see what I just did? Let's say I don't want to put this part in anymore. I can just go up to Format and say comment out region, and it'll add them for you. And then you could do the same thing. You could highlight that region and uncomment out.
So Dr. Rayler.
Yeah.
So in C++, you can do the slash star and then do star slash. There's nothing like that in Python.
No. Sorry.
Okay.
That's correct. Okay. All right, so now the number of times E appeared. Okay, let's do this. Let's take this code and generalize it so that we're going to change my name to be any possible string, and we're going to change letter to any possible letter. Okay, what we're going to do, I'm going to save this as a new, I'll save as a new example. What we're going to do is make it so that we're going to create a function, and when we call it, we're going to ask for both a string and a character in our function. So let's start that out. Let's say def count char, stands for count character. Okay, so let's say that I've got my function here, and I want my function to have two parameters, the string and the character that we're testing. Okay, so what's a good, how many parameters am I going to have here then? We can think of whatever we want to as the names of those characters. I mean, the names of those variables. So what should we call the string that we're going to test?
Test string.
Yeah.
Test string. And then what about the character that we're going to count? Because we're going to count up the number of times it appears.
E.
E? Sounds good. All right, so that's how we create the function. Now we want to put this code, I'm going to comment this line out for this one. I'm going to take this code, format, indent region. Okay, now, delete that for now. Let's take our code. What do we need to change in order to make this general? Because it's no longer my name. What do we need to put in for my name? Because we want to test any, what's that?
Count char.
It's a good guess. Test string. Yep. Test string is going to be the string that we're testing. What about E? What do we need to, because E is now the thing that we're trying to test and find out how many E's are there. But it's not really E's. It can be anything the user puts in, but we decided to call it E. All right.
We take the quotes on either side of the E out, right?
Exactly. We'll take the quotes on either side of the E out because now it's the variable being called E. So if this letter is equal to whatever variable was fed to us in our function, it's going to increment. So now we're counting up the number of times the E, which could be A, B, C, D, E, F, G, H, I, J, K, L, and P, what could be, sorry, something alphabet's on P, it could be any of those. And then we're going to, somehow, we want to return to the user the number of times that we encountered an E. So what do we need to do that? Or return out of the function. Not necessarily to the user, but just get rid of this for now too. Yeah, we need to return T. What if I put it right here? What's going to happen? Is that logically the right place to put it?
No, it needs to be under the 4. Right?
Yep. Yep. So now if we put it right here, it's still only going to run once because it's going to run the for statement. So you're right. It needs to be under the for. So this will go all the way through its loop. However many times, however many characters there are, it's going to go through all of them. And then once it's done checking every single letter, then it's going to return the number that it's in T. So let's write a test thing here. We're going to print count char and say test string George. We're going to test it with the same 1 and then E. Okay? All right, so what should we get when I run this? What's that?
2.
Just 2, yeah. Because it's going to print, it's going to say there's 2 of those in that. Let's go. All right, so now I just took some text from the web page at the University of Southern Mississippi, and I'm going to run it. And it's going to tell me that there are 10 lowercase e's inside of that string. So there's 1 here, 2, 3. Must be a few more of them off the side of the camera. But I missed one at the beginning. I probably missed a bunch of them. Let's change this to capital U's because I bet you there's only 1 capital U. One. Yep. So that works. That function works, and we verified that it works. And it counts up the number of occurrences of a string. Something that might actually end up being more useful is trying to find the number of spaces. So that would be the number of spaces. There are 16 spaces in that sentence. Because even a space counts as a string. Okay. So the University of Southern Mississippi is one of the 76, so there's 16 spaces across there.
Dr. Raver.
Yeah.
That last line of code, print, count, char, and out with insertion. Is that a way for you to just test your code without the user input? You're actually just plugging in the variable you want to test in the parameters?
Yeah.
Or the whatever it is?
Yes. Yeah, I was just calling the function. I could make it a little bit more verbose and say, text test equals Control X. And then test R equals quote, and then just change this to test text, comma, test. So now I could, like in the future, I might get these from the user or whatnot, or I might be reading a file. Next week we'll talk about that. I might open up a file and be looking for a certain piece of text, or a certain character. And technically, this function would actually tell us how many times, like, I could change this to, oops, I didn't mean to put it there. It'd be easier to leave here. I could change this to Southern. So here, oh no, I can't, because that's not what never mind. Got ahead of myself. I can't do that. But there is a way you can do that. Yeah. There's already a function that actually does that. The in function, you could say, is Southern in the character. Okay, one thing that I wanted to do, the book points this out, is sometimes it becomes helpful to see if it's upper or lower case. So like for U, okay, there is an upper and a lowercase u. So if I pressed U or I pressed U, I'm going to get a different answer. So I'm actually going to go save and then file save as, because I'm going to change this to, the way that we can do this, the way we can test for uppercase characters is to run a function on the string that will take the letter and convert it to an uppercase character. And then it will always test against the capital version. So now if I run this, it'll say there's 4 U's. So there's 4 U's. There's one here, there's another one here, there must be some others. There's another one and there's another one. So there's 4 U's. And so what the upper function does is it takes a string and it returns a new string that's a fully uppercase version of that string. So some people might say, I don't really care about case. I want to not check case. And that's important, like if you were trying to check to see if a file was a JPEG. Because in Windows, it allows you to name the file, you know, mypicture.small JPG or large JPG, and it doesn't really care. They're both JPEGs. It's not case sensitive. So that's an example there. It's not really has anything to do with sequences, but it's a string function. All right, sorry, did I interrupt you?
I was just verifying what you said. So that basically is taking the input and adjusting it all to uppercase before you check whatever is in your sequence.
Yeah, pretty much. Technically, since strings are immutable, they can't be changed, it's taking your string and converting it and returning a new string where everything is updated. So, I mean, just drive home what I'm saying here. If I said A equals George, and I said B equals A dot upper, print B. See how B is big? But if I print A, it's still small because you can't change the values in A. I could say A is equal to B, and then now I can print A, and everything will be big. But that's because I just totally wrote over A and got rid of the old A. All right. I mean, that's just a small technicality, but it is the way things are. Okay. We looped through. We counted. That's going to become a little bit more important later when we talk about the next thing, which we're going to talk about now. So. What if we wanted to well, okay, not what if. Let's just talk about the next one. I'm going to save this. I'm going to close it. and create a new file. Actually, I think it's easier just to go like this, delete everything, and then save as, and call this 5, example 5. So sequences aren't, I mean, strings aren't the only sequence. In fact, they're not even close to the most useful sequence, although strings do get used a lot, right? But there is a very general sequence that you can store any data type in it, and it's mutable. You can change any of the values. That's kind of like a catch-all. So Python uses them a ton. It's called a list. Okay, a list is actually created by using the square brackets. So if I wanted to say my list equals, I need to use the square brackets, and I could use the square brackets again. This creates a brand new list with nothing in it, an empty list. I could even write a comment that says that. This creates an empty list. Right. Now, what if I wanted to create a list? Let's call it a list of cities, and I wanted to actually put something in it. Well, sorry, that double quote didn't need to be there. Cities. Well, I could do that by going like this. Hattiesburg, comma, Mississippi. And then I separate the elements in my list with commas. You feel free to put whatever cities you want. That's where I grew up. Comma, so this is becoming a list of cities that I've lived in. All right. And then finally, if I want to finish up my list, I put a little an extra closing square bracket. So now I've created a list of cities. I can have lists of numbers. These numbers might represent the ages of people in one of my courses. Oops, sorry, I meant to put the little bracket. So like a really smart kid. All right. So that's the ages of everybody. So that's another list. Now, technically, lists aren't like I know some of you guys have taken C++. Maybe some of you guys here have too. They're not like what we call arrays in computer science. We can mix the contents of the list, although you don't usually want to. But you could just write stuff and say 55. Thing, false. Oops, I gotta spell false right though.
Is that going to return a 0?
No. So lists can have any data type, and you can mix data types in them. So that's what I'm trying to get across. Is that that list of stuff is a fine list. Now you might have trouble, like if you said 4 item in stuff. First time you're going to get 55, then you get that, then you're going to get thing, then you get the false, then you get pizza, then you get 56. You might have a hard time doing anything with that list. But you can do it. Just to show you that it can contain a Boolean, it can contain a number, it can contain strings, I forgot. It could contain negative numbers, and it can also contain decimal places. So this is just to demonstrate that a list can contain any data type. Right? And since I said it's mutable, you could actually swap out any item in the list. Like I could change this item to something else, that item to something else, change all the items in a list just by indexing them. So,
Dr. Greg,
yeah.
since you brought up arrays, do we get into arrays in Python in this class, or?
Yeah, we're going to get into arrays in this. So there's a special module just for handling arrays. It's called NumPy, N-U-M-P-Y. NumPy, that's what it's called, for reals. We'll skirt it. We'll talk about it a little bit 2 weeks from today. And then, yes, when we start talking about dealing with rasters in GIS, we'll talk about now, because basically you can take a raster and you can convert it into a bunch of numbers, and those bunch of numbers is an array. If you don't understand that, we'll talk about it later. But just to answer your question right now, we can. But these are different than arrays. This is just a list. And you can actually even have lists of lists. So kind of like arrays, you can have a two-dimensional. That's a way you could create a two-dimensional construct. So you can have a list. A list contains a list. Sorry, that's not right. A list that contains lists. So the first dimension would be which list you want, and the second dimension would be all the items in that list. So in a lot of ways they're like arrays, but they, as you can imagine, being able to put any data type in and being able to change any data type at will is a lot of overhead for the computer. And so the disadvantage is that for dealing with really large data sets like a raster and getting changing all the values in there, it's inefficient. So you wouldn't want to use them for that. But if you're talking about taking all the GIS files in a directory and doing something to them, like updating them or make sure they updated at some point, or overlaying, taking a big list of all the files and overlaying all of them using some overlay operation, lists are used for that. Okay, so that's why they're useful. That's why we're talking about them. But see, I just entered my my stuff, this thing called stuff, and if I said print stuff, it's just going to print it again. If I get any item out of stuff, I could print an individual item like stuff 4 gives me the fourth element, which is pizza. 0, 1, 2, 3, and 4. Okay. And this didn't work before, but if I wanted to change stuff 3, which was false, and I wanted to change it into true, I could do that. In fact, I can change it to any value. It doesn't have to be a Boolean. I can make stuff equal to stuff 3 equal to big. So I can change any value out. I can change the data type of any value, those are all characteristics of strings. We have lists, so they are immutable.
Are the lists treated like index and the sys? They all start with 0.
Yes, they're a sequence in the same manner. So it's a list means that all items are indexed the same exact manner. 0, 1, 2, 3, 4, starting with 0. Okay. Just like strings, you can concatenate lists using the plus operator. So I could add, I could make a new list called, you know, so I'm going to run this. So I can take two lists and add them together. Just like, remember I concatenated, that's what this is right here. I concatenated two strings, and I can concatenate two lists. So it contains all the elements in both. In fact, if there's a repeat element, let's test that real quick. If there's a repeat element, then that element now repeats. So it's literally the stuff from the first one and the stuff from the second one. See how 56 is now in the list twice. So it doesn't like find the intersection of the list. It just throws them together. Okay. You could slice lists just like you could slice strings. So I could say I just want the first two elements, or two until the end. So now when I run this, I'm just getting two until the end. See, it's starting right there and getting the rest of it. All right. Now, one of the good things logically, in order to build programs, oftentimes you need to do things to lists. And those things that we do to lists a lot, we're going to loop through all the elements in a list and do things. And there's three different categories of functions that will operate on lists and change the list. The first one is called map. The second one's called filter. And the third one is called reduce. A map does not mean anything about geography. Okay? A map function takes a list and it converts all the values in a list to some other value. Like let's say I had a list of cities. A map function might take every city and capitalize all of the items in the list and return a new list of all the same cities, but they're capitalized. Okay? That would be a map function. Or it might take all of the values and they might represent the ages of the people, and say a year has gone by, it might allow me to add an arbitrary number to every item in the list, like 1. So I could use a map, I could write a map function and take every item in a list and add 1 to it. Let's actually do that example. Okay, I'm going to go File, Save As, and I'm going to call this example 6, and I'm just going to delete everything except for the ages because I got the ages. So this is going to be my map function to add a number to every item in a list. Okay. We're going to learn something about passing items to lists too. So here is my my function. Let's just call it increase. I can add number. How about just add n list? Okay. I don't want to make them too long. Okay. So then it's going to take a list. So let's call this just my list, because it's going to take any generic list and it's going to add a number n to every item in that list. Okay? All right, so how would I do this? Well, the first thing I'm going to do is do for. I'll just say number in my list. Now, what's going to happen when it enters this loop? How many times is it going to run? How many times is this loop going to go through? Until it stops, but what's going to cause it to stop?
We tell it to stop.
We tell it.
Wouldn't it keep running through and through?
What's that? Right.
something else.
Until it's gonna run exactly the number of times as there are elements in my list. So if there are 10 elements in my list, this will run 10 times. If this is 20 elements in my list, it's going to run 20 times. But it's a function, so we don't know yet how many elements there are in my list. Now if we feed ages into this function, it's going to run 1, 2, 3, 4, 5, 6 times. Okay? And the first time through, if we put ages here, the first time through, it's going to equal what? Number is going to equal what? 23, then 25, then 45, then 11, and so on. All right, so if I want to take the value of ages and I want to add a certain number I want to add n to the first item, the second item, the third item, and so on, how do I do that? I can just go number equals number plus n, right? Let's see if this works. So let's call this function add n list ages, and let's just do 3. It's going to add 3 to each one. Print add n list. Now let's see if this works. Now you're probably thinking that it won't work. Maybe some of you are. What are some problems that you see that might be encountered here? N is 3.
Add the previous age to the next age.
Now what? Okay, let's think. If ages goes into this function, the first time through, number is going to be 23, right? Okay. 23 equals, sorry, well, this is evaluated first. 23 plus n is going to be 24, 25. It's not actually going to go back to the last number ever, so I don't think that's going to be an issue. I'll run it. Oh. I didn't mean to do that. I meant to say print ages. Right? Did the numbers change at all? Let me make this smaller. They didn't do what I was expecting them to do, right? Did the ages numbers change?
No, we didn't return anything.
We didn't return anything.
That addition was local to the function and was lost when we went back to the main part of the program.
Right. That addition was local and nothing changed here. So we could do something inside of here. We could create a new list and set it equal to nothing. And then each time through the loop, we could take our new number and put it into that list. See what I'm saying? So here is a better way to do this. Case sensitive. So here's a new skill, or a new function. Append takes a value and puts it into a list. Append puts a value onto a list. So new list dot append, and then this puts a value, shoves a value into the number. Shoves a value into the list. In our case, it is a number. Now we still have to do one more thing, and you already said it down there on the coast.
You got to return it?
Yes, we have to return our new list. So now, if we run this, it still won't actually work. Okay, what do we have to do to actually get new lists out here? we can't print that new list because that's still only local to here. It is going to return it. What's that? It is going to involve an equal sign. So we have to come out with a way, like we could say new ages. I guess that sounds like new age. New wages. Knee wages. But we could print this knee wages. Yep, see how it prints these numbers? Now they're all added, 3 is added to every single one. So we had to create a new list, and then we had to build our new list, populate our new list with the values. So this is a map function that creates a new list. It does not modify the values in place. All right? I'm gonna show you something that is gonna be. So I'm gonna save this. Watch this. Actually, I'll save it as something else. Okay. So now, what I'm going to do is change this slightly. Well, actually, it's pretty significantly. Remember, we said that lists were mutable. So if I say index, I'm just going to say I is equal to 0. I'm not going to create a new list this time. What I'm going to do is, each time through the list, I'm going to say I equals I plus 1. And this time I am going to say my list equals my list index equals number plus n. Yep. And now I'm just going to print ages. I'm going to try to run this guy. My list. Oh wait, I didn't ever call it. I took out that. Yes, no return. I'm doing something different. Demonstrating something new. Oh, there's no return. I just need to print ages. Okay. This will work. Okay, now look. See how I printed ages, and those ages have all increased, and I'm still printing ages. The reason that happens is that a list, because it's mutable, because it's changeable, even inside of a function, changes to a list will persist outside of that function. Now, you were right. I still can't get your voices right over to the IVN, but you were right when you said number is local to the function. Number is local to the function, but my list is a local name for a list. And because it's a local name for a list, it will persist outside of the function. So when we increase or decrease or change the value of my list inside of a function, if it represents a list, it will actually change those values. And sometimes we refer to that as, so Python, when you pass a list into a function, it passes it by reference, not by value. And so it's giving it a reference to the actual variable. So if you change it, it'll change. So I'm going to write something like values of ages were modified in function. So this version of the program. Example 6 and example 7 did almost the same thing. But example 6 creates a new list, and example 7 takes the list and modifies the values in place. They're both map functions. Okay, they both take every value and they do something to it. So most of the time in map functions, there'll be the same amount of elements in a list in the output list, or the list that gets changed, as there are in the input list. So that's the rule for map functions. All right, I'm going to do reduce second. So we did map. A map function changes every value. A reduce function summarizes. So I'm going to go like this and say my reduce function summarizes items in a list. I'm going to calculate the mean. So a reduce function takes a list and it boils it down to like one number and tells you something about that list. That's a very simple reduce function. Might just tell you the count of the items in the list. Okay, we've already written something like that, right? So here, my function, I'm going to call it def find mean of my list. I don't need any other parameters. I just need the list. And I'm going to find the average value in the list for number in my list. Okay, so how can I find the mean of all the items in a list? What would I need to do? Don't think about the programming yet. What would I need to do to find out the mean of all the items in a list?
Add
them all together. Yep, I think I heard that. Then what's the second step? Right, so I need to find out what the total number of items is. Now, in Python, there's already a way to do that, right? Like I don't need to keep track of that on the loop. If I wanted to do like a weighted mean, I might need to keep track of it in the loop. But just to find out how many elements there are, how can I find out how many elements there are on the list? The len function, exactly. So at the end, I could have something like mean equals something divided by the length of my list. Okay, so that's how I could get the mean. But now I need to find this something, this question mark, right? So how do I get the total of all the items in the list? Yeah, I need to do a sum thing, right? So I need to do something. So, well, yeah. No, I know what you mean. So sum looks like it's a reserved word. So let's do dot equals. We've done this before now. So the total, I need to set it up and set the total equal to something. We did this last week, right? So if I start off with the total equal to 0, how could I, for each item in the list, how could I take total? I'll just change this right now.
Or number in my list, total plus 1.
Yeah, I called it tot, but tot equals tot plus 1. Now, is that going to work?
No.
Okay. That's just going to make total go up by 1 each time. I want it to actually go up by, it's kind of like distance last week. I want it to go up by the number. Does that make sense? So it's going to be the total
plus minus bracket, total plus bracket.
Well, I would do total plus equal number.
Okay.
Because number contains whatever element in the list you have to be at, right?
Yes. Yeah. Exactly. So on the coast, they're really pushing for this shorter version. But these are equivalent statements, just so you know. Tot plus equals number is the same thing as writing tot equals tot plus number, and they will both work. So now I needed to return the mean, and I'll be done. Okay, so let's test it. So I'll say print find mean, and then ages. So now it's going to find the mean of those values and return the number. So the average is 35. Now that's the integer average, because we didn't tell it to do anything like change the units or anything like that, or change it to a float. We could have done that. We could have done that down here. We probably could have just done it right here is where I would do it. Okay, you don't need to do it anywhere else, because the ages will always be given in whatever units they are. So now if I run this, I'm going to get 35.333333. That's the average. That's the average age. So that's a reduce function. You could write a reduce function that calculates the total number. Like I could just sum all the values up. I could return total. That would still be a reduce function. Okay, so you've actually already written a reduce function because you calculated the total distances last week. It just wasn't written as a list. All right, you could write a reduce function to calculate the standard deviation. That would be more complex. How do you calculate the standard deviation? We'll go over that in the lab because it is a one, but it's really easy. But it does involve a second loop because you need to figure out the distance from all of the ages to the mean. So you need to write another loop where you calculate the distance from each observation to the mean. So the mean minus each observation. Anyway, we'll do that when we get to the lab. And we'll get to the lab soon. There's only a couple more concepts that I want to talk about. The second to last one here is reduce. We need to reduce. Okay. So we did reduce. We need to filter. So a filter function takes a list and only returns the values that meet a certain criteria. So a filter looks through every item in a list and decides if that thing meets the criteria, and then returns just those items. So you might be looking through a bunch of file names, and it only returns the file names that are JPEGs, or only returns the file names that are shapefiles. That would be an example. That would be a geography example. Or with our numbers, it might look through all the numbers and only return the values that are greater than a certain value. So that's the one we'll write really quick here. Def, we'll call it nums greater than. So we need a list, and we need a number, like a cutoff. So it has to be greater than a number. So we'll just call that n again. N will be the value. All right, so in each of these, we're going to start off by for number in my list. And this one's actually going to be easier if we create a list, a second list, like we did before. Because we're going to just put everything that meets the criteria into the new list. We're going to put it into the new list. So if we get a new number, if we get a number that meets the criteria of being greater than n, it's going to go into my list, into the new list. So how do we do that? How do we check? How do we check if a number meets that criteria? What kind of statement do we need to write? If, yep, all right, if, we're trying to check if n is greater than, or sorry, if the number is greater than n. So we'll just go number greater than n. And then what are we going to do? What do we want to do? We want to put a number into the new list if it meets that criteria. So how do we put number into the new list? We did that in example 6, append. Yeah, exactly. So we just go new list, append, and then put in the item. So what item are we putting in? Number. Yep. Okay. And that's it. So then we can return new list. Okay. So now let's write this horribly named function. Let's write something that we'll call it. So we'll feed it ages, and we'll give it an n of, let's say 30. So everybody, all the ages over 30 will be returned and reported in the new list. So let's see if this works. I'll go back immediately to it. All right. So this was the original list right here, 26, 28, 48, 14, 37, 59. And it returned all of those that were greater than 30. Let's see if it works. That's greater than 30, that's greater than 30, that's greater than 30. Are there any in here that are not greater than 30? No. So that's an example of a filter. So a filter function has to have an if statement that looks and sees if a criteria is met. If it is met, it builds a new list. I think that it's easier to do it the way we've done it. If you did want to change it in place, I think the easiest way is to replace the return statement with a statement like this: my list equals new list. And that's technically not, I mean, that's technically just writing over my list. Okay, but it's hard to, like, in the middle of a loop, to take out elements of a list and get through the loop logically. Can you see what I mean? Like, there is a way to remove elements out of a list, but I can never get the programs to work right if I'm removing elements from the list as I'm looping through them. See how I'm going through every element in the list? So it's easier for me to just build a new list and then copy over it if I want to replace it in place. That's just the way I understand it best. There is a way to delete an element in a list, and it's discussed in the book. There are a few different ways. Let's just make a list here. Or actually, I think I just have. Let's see if I have ages here. Okay, yeah, I do. Okay, so let's say I want to remove just the first element of the list. That is called pop. So ages pop, or sorry, the last element. Ages.pop will remove the last element in the list and actually returns it. It's a function, and so it'll be returned to you. Now if I print ages, then it's gone. It's removed. Okay. You can also.
Is it printing it out? It's removing it from that function, like altogether, permanent?
It's permanent. It permanently removes it, but it is a function, and the function returns the value it removed. That's why it printed it there. Is that? Do you have a question about that, or?
No, sir.
Okay. All right. So if we want to remove an element by its index, we can do del, and then say ages. Let's say we want to remove the second, which would be 48. So we're deleting ages from the list. Now if I print ages, it's gone. And you see there that this didn't actually return anything. It's not a function anyway. It took the second element out and killed it. And so it's not in the list anymore, and it didn't return it to us. That's just... So you can see if I tried to use that in the loop, I would have a problem. Because if I tried to remove an element, the list would move up one, and you never can predict what the for statement is going to do at that point. So don't delete elements of a list in the middle of a loop. All right. You can also remove an item just by just by repeating it. So like it's called remove. So if you said ages dot remove 14, it's going to remove the value 14.
Not the index.
Right. But you see how that actually says remove, and these are curved brackets.
Yes, sir.
Okay. Let's see. Let me look at the homework. There are a couple more concepts, but kind of getting toward the end of. I'm just going to see if I could push those to next week. But I want to look at the assignment here real quick. Make sure. So we did this. These are the ones that I didn't filter. Oh, I did filter. I didn't do special functions or zip functions or range functions. Oh, I do need to do range. All right, I'll do range here real quick. And then okay. Yes, I think we're good. Yes. Okay. So one more thing is that there's a special function that'll create a list. I'll just do it over here because it's an easy function. So if you say range, and then you give an upper and a lower bound, 4, 10, then it'll make a list, 4, 5, 6, 7, 8, 9, it doesn't, not inclusive of the second number. So it makes a list of numbers that start at the first number and end just before the second number. So there, I mean, that may not sound super useful, but you could go 10, 100, and it'll give you all the numbers between 10 and 100. Also, you can put a step value. So now it'll do from the range to the range by this range. So see how it's on 10, 20, 30, 40, 50, 60, 70, 80. You could even do range 1 to 200 by 12s. You know, so now you've got if you were like iterating through a bunch of months, you've got every number that would represent a January. Like, let's say you were going through like the first year, January would be 1, and the 13th time through the loop, January would be 13. And so anyway, you can do any step that you want that way. Now the reason why that's important is, I'm going to go ahead and save this and create a new one, is that when you do a loop, you can say for x in range, and then create a range. So those of you who have taken like a C++ course, it's the equivalent of writing something like 7, 8. So now that prints 4, 5, 6, 7, 8, 9. It's the equivalent of writing something like, I forget the syntax, but in some other languages you can actually say 4x equals 5 to 100. It's the equivalent of doing that. So this is the only construct to do that in Python. So if you want to say 4x in range, you'll iterate over every single number in a particular range. All right. Well, let's go ahead and take our break then, and then we will work on the lab assignments. We'll get started on all 3 lab assignments this week, and then we'll break for the day. Okay, so let's take a 15-minute break. Be back at 3:15.